Right, welcome back again. Grade 10 grade 10 learners. In this video I'll be taking you through the question 2 of waves. Okay? Now, let's study this. Each particle in the wave shown below completes on vibration oscillation in 0.3 seconds. Now, if you can check, the first question is, what is the amplitude of this wave? Okay, we look at the amplitude of this wave. Let's see what is happening. And then the amplitude, is it given there? Let's look at it. We're going to see there, what do we have? The amplitude. The amplitude is going to be 35 divided by 2, because from here to here is 35. So the answer for 2.1, let's look at it. The answer for 2.1, you are going to say 35 divided by 2 is going to give you 17.5 millimeters. But remember, it should be in meters. So you are going to say amplitude is equal to 17.5 over 100. You see, over 100. So the answer you're going to get, it will be 0, or no, not to over 1000. Yes, 0.0175 meters. So that is the answer, class, because remember, from here to here is 35. So the amplitude is from here, the starting point, the rest position. So you can see that even here it's 17.5 meters. Even here, 17.5 meters. Okay. Now, let's come to the next question. We are done with this one. It's 0.00175 meters. What is the period of this wave? We are talking about period is time. Okay. It's given up there. 0.3 seconds. 0.3 what? Seconds. That is the answer for that. Now, what is the wavelength of this wave? The wavelength of this wave. Okay. Now, you can see that the wavelength is from where? The wavelength is from here. It's from here up until this part. This is the wavelength. Or it's from where the wave start. You see, where the wave where it start and complete. Let's say from this point up until this point. You see, that's a complete wave. Another complete wave is up until here. This is, let me say, 0, 1, 2. So which means you have two waves. So how do you solve this one? Let me write it here. 2.3, two waves. So it means you're going to say 0.8 in a simple way, you're going to say 0.98 over 2, which is going to be 0.94 meters. That is the answer for this one. Let me write it, 0.49 meters. Why am I dividing by 2, learners? Is because we have two waves, two complete waves that are there in this question. Okay, let's go to the next question. Calculate the frequency of the wave. Let me write it here. It's 2.4. What do we do in this 2.4 frequency of the wave? We have a formula. F is equal to 1 over T. 1 over, what is the time that we have, class? It's 0.3. So which means when you press your calculator, you're going to get 3.33 what? Hertz. That is the answer that we are going to get in this question. Let me write it. 3.33 what? Hertz. We are good on that one. Let's go to the next question. Calculate the speed of the wave. Remember the formula to calculate the speed is V is equal to F lambda. Okay. What is the frequency class? You got it. It's 3.33 multiplied by what is the wavelength? It's 0.49. We know this one. Then you press your calculator, it will be 1.63 meter per second. Right? Now let's go to our last question. What is our last question all about? How long will it take? How long will it take 8 wavelength to pass a specific point in the medium? How long will it take? Okay, 8 specific wavelength. Okay, so now, which means that one oscillation of particles produce one wavelength. Don't forget about that. So one wavelength passes a point in 0.3, one wavelength. So which means if there are 8, it will be 8 multiplied by 0.3 is equal to 2.4 seconds. Okay, let me write seconds somewhere there. Right, class, that's it. Thank you. That's all for question 2 about this transverse the transverse waves. All right, till we meet on the next video.